Hello and welcome back to Calculus 2, section 7.3, trig integrals. We talked briefly about trig integrals last class. I asked you to review extremely important formulas. First I said make sure you know calculus pairing for trigonometric functions, which is sine with cosine, secant with tangent, and cosecant with cotangent. And I also asked you to remember the basic formulas for trig identities, for Pythagorean identities. And then I also told you that each one of these would have extra two forms, right? Each one of these would have extra two forms. If you solve for sine squared, then you can solve for cosine squared. That one is solved for 1. The next one can be solved for tangent squared or 1. And the last one can be solved for 1 or cotangent squared. So you need to know all 9 forms, right, to recognize them. Then we went from basic Pythagorean identities down to double angle formulas. And the cosine, because you have sine cosine squared over here, you can actually have 2 more forms by using the Pythagorean identity. And then the most important of all, these two guys right here, power reducing formulas. The only way you can solve integral of sine squared or cosine squared is to use these power reducing formulas. There's no other way around, so you must know those. And then the list of all of these from Calculus 1. So we haven't learned anything new. Yes, Lou? I guess air conditioning unit had more food than you, so.
Well, I was working on 7.2. This will get a quick question.
Yeah.
You know how you do the U, du, dv, and v?
Okay.
When you do the dv, take the integral?
Yes.
For v?
Yes.
Okay.
And I asked you guys at the end to expand as a practice, a skill that we need for today, to expand sine to the 4th to the point where there are no exponents. And I think you're seeing that you have to use the power reducing formula at least 3 times to do that. We are going to Tonight, we are going to put the integral dx and solve this using the expansion that you had at home. Now let's take a look at today's lecture. So some of the integrals you already know. For instance, you all are supposed to know how to solve sine to the 8x cosine x dx. How do you solve this integral? This is Calc 1 integral, but it's the first integral of this section. How do you solve this? U sub. Very good. So this is a trig integral because you have trig functions only, and it's a trig integral. We are using basic U sub, where U is equal to sine x. Very good. Du equals cosine x dx. Very good. I'm going to underline cosine x dx. So now we see that this becomes u to the 8 du, which is u to the 9 over 9 plus c. Now the sentence, right? I don't care about u, care about the x, which means go back to x variable. We have 1 over 9 sine to the 9x plus c. And the problem is solved. So 100% of you need to know this integral right now because there's nothing to do with Calculus 2. This is, as you can see, basic U sub from Calc 1. In Calc 2, we make this a bit spicier, but, so this is now Calc 2 version, by writing sine to the 8x cosine cubed x dx. So this is the problem that it's a Calc 2 version. So this is what you're expecting on your exams and final and all of that stuff. So now when you are looking at this integral, everything is the same except that q, right? Now, the reason why I underline with red cosine x dx is because that is the string for du. Now, I hope that you see that we can peel off a single cosine, leaving cosine squared behind. Do we all see that? Because cosine squared times the cosine is cosine cubed. Bueno? Good. And now I do have this, right? So that's going to be our du. But then we have the cosine squared. Look what's happening here.
It could be 1 minus sine.
Very good. So the entire integral must be in terms of sine, leaving a single cosine for du. So those two cosines that are left there have to transform into sine. And as Lou said, 1 minus sine squared x will fix that. So now, if you distribute, you're going to have, we have to use parentheses, sine to the 8x times 1 is sine to the 8x, minus sine to the 10, very good, x, all of that times cosine x dx. We are using the same u sub, u equal sine x, du equal cosine x dx, and the problem now is u to the 8 minus u to the 10 du. This is the Calculus 2 version where we are combining the formulas from Calc 2, right? From PreCalc 2 for Trig. We used, right here, we used Pythagorean theorem to transform unwanted cosines into wanted sines. Now, this is what I said when I said you have to know all of these formulas. That's what you're going to use them for. All of the Calc 2 versions of these problems will have these formulas or the ones in red. So you absolutely must know. Maybe I should put the red box around these guys as well. So whatever is in red boxes is going to be used a lot. The ones in the middle over here, we'll see what we're going to use them for. We'll use them as well, but it's not as much as these. So now, basic integration. We have 1 over 9 u to the 9 minus 1 over 11 u to 11 plus c, and then go back to x. 1 over 9 sine to the 9 x minus 1 over 11 sine to 11 x plus c. If you don't believe me that this is the answer, go ahead, take the derivative, and you will see it will work out fine. To what?
If I take the derivative of that, isn't it only counted to check?
It will, yes, that's how you check integration. Give me 1 second.
Class is over.
Special delivery.
Oh my god!
Oh, I can sit down now. I can sit down.
When did you get more than 4?
I don't know. It's a delivery. Where's my pen? There we go. I'm in this array now. Okay. Well, thank you for the delivery.
Your pen green by any chance?
I'm sorry?
You have a green pen?
This is blue, I hope. It's weird blue, but it's blue. What happened?
It had do you know your blue isn't physically green?
I actually don't. Yes, this could be green, which case I have no clue what the color is that you have right now. Let's put it up. So, yeah. He has something that I would call green. Next, in our... Well, actually, it's good for you to try one of these. I'm going to switch this on you. So let's go with the cosine to the fourth x times sine cubed x dx. Let's see how this goes. So for you guys. Exactly.
Yeah, I packed myself 3 lunches today, and I ate them all by like 12 o'clock.
I had
Is he turning into you?
I know, too much math, so we're gonna be the same. Fat, no hair.
I was saying about the meals. Like, I mean, yeah.
Why stop at one?
I would make my mom broke.
Are they 7 like small meals or 7?
No, there's 7. Dude, they're like 7.
3 are serious ones. The other 4 are not.
The other 4 that he doesn't consider serious are pretty much a dinner challenge. Of normal people.
You want to like 15 pounds.
I jumped ahead already.
Wait, so what if I write minus here?
We will laugh, but it will still be correct. Just would be weird, you know?
Also, can I like write all my numerical answers in binary?
Go ahead, write the
On
software.
my test.
No. This test is going to be terrible for me to grade, so no.
I'll do it for the final, the last question on the final.
Okay.
I feel like you're the guy that would like fuck your best guy friend's girlfriend.
Yeah, I mean, now I have to
Yeah, Adam. He's messaging. That's like
still at the new stage where
Do we all have the same answer?
Yeah.
Very good. I will just quickly remind you that if you, as you can see guys, between these two lines, what I did is I swapped the order. When you swap the order in subtraction, the minus sign pops out, right? And that was the minus that was used to counter the minus on the derivative. Do we all see that? Yeah?
So what do you say about the sign with the negative sign?
What happened?
What do you say about the negative sign?
So when you swap the order of these two, a minus pops outside, right? And that minus and the minus sign x is exactly this string, so I don't need the additional minus signs. What we've seen now is the procedure for integration of sine and cosine functions when you have one of them to have odd exponent. If you look at 3 examples that we had so far, at least one exponent was odd. You can have both exponents odd. In that case, you can pick whatever you want to use for du. Hell breaks loose with even exponents, because you can't use u sub. With even exponents, you don't have, it doesn't matter. Well, let me write out an example first. So if you have sine squared x times cosine squared x dx, so both exponents are even. This problem gets exponentially more annoying with higher exponents. So if you have 2 even exponents or just one even exponent, u sub doesn't work anymore, because u sub always calls for one of these guys to peel off, right? So either sine or cosine, whatever you want to leave for du, and then you would have odd number left over to transform, but your Pythagorean formulas are all squares, so it doesn't work. So if I pick off, let's say I peel off a cosine, I will have sine squared x, cosine x dx. Sure, this is left for du, but see, you cannot transform this one into sine, so you can't use u sub, because it's 1 minus sine squared x, right? Cosine squared, you need a cosine squared and you don't have it. It will be the same thing if you peel off a sine. So we cannot solve all even powers. We cannot solve with the method of u sub peeling off 1 from odd and transforming the even ones back into the other function. So we have to do something else. And that something else is power reducing. It's the only thing that you can do. So we are going to write sine. So for all even exponents, use power reducing. Sine is 1 minus cosine 2x over 2, and cosine squared is 1 plus cosine 2x over 2 dx. This will give us 1/4 in front of the integral. And now when you FOIL this, you get 1 minus cosine squared 2x dx. What now? Sorry, what did you say? This is equal to sine squared 2x, and then power reducing again. Yes. This is how beautiful this is. So 1/4 sine squared 2x dx. Guys, I understand that you learned the formula as sine squared x plus cosine squared x equals to 1. But this does not have to be x. No matter what here, no matter what you put there. There you go. Still works. That's a heart. I figured. I mean, Valentine's Day is coming up, so. Yeah, it is. It's February, right? What do you mean no? They moved it? All right. Time is relative. There we go. So remember that the 2 will pop out, so we have 1 over 8 now. Integral of parentheses 1 minus cosine 4x dx. Make sure you are always doubling your angle. If you're starting from x, you will have 2x. If you're starting with 2x, you will have 4x, and so on. Those are some frequent mistakes. And now we can finally integrate. No more squares. So 1 over 8, integral of 1 is x, and integral of negative cosine is negative sine 4x over 4 plus c. You don't have to distribute 1 over 8. You're technically done here. That's you know. Yeah. Come on, Red. So we're done there. When you have all even exponents, you can have just sine, just cosine, or combination of sine and cosine. If you have only even exponents, the way to do it is power reducing formula. If you don't know power reducing formulas, well, tough luck, right? Pick a different major. How about that? Yes? I use the power reducing formula here. Right? Power reducing is over 2, so a half from power reducing and a quarter in front. Quarter times half is 1/8. Since you all spend time, right, working on sine to the 4th expansion at home, I don't want that to go to waste. So your next example is use your expansion you did at home to do this.
You either fly for it or you die.
See, I don't see why you think yeah, so our strength rate 2 will not be cosine squared of square x squared.
Yeah, I know everything.
Yeah, so do that.
I wired those.
Yeah. So tan equals 2 minus cosine squared of cosine of 2x. That's standard. Well, that's just annoying. Well, so what I did here is I skipped this step, but now I don't have a 1/4 or 1/2 there.
Oh.
So what he did and then what he did is he said that's 1 minus cosine.
confused when I get into that.
Oh, you got
Wait, you're taking calculus next semester?
Okay, he said that's right. And then he said,
No,
I don't think it's part of
depends on your prep, depends on your integration. A lot of students that are weak in integration are going to have huge issues. Yes, and if you don't learn from our series,
I'm
so
confusing myself here.
integration by parts, chapter
That's
4,
where that
plus
equals 1 minus this.
integration by parts, plus the plus superposition or integral plus.
Well, I'm
And
doing
then
this times that.
for chapter 3, our
Wait,
series,
that's the same thing.
is our
Well,
chapter
it's not
9.
because
So
this
if
is
you
not
don't
fraction,
know
this
these
is-
three
this would be
concepts
four.
from Calc 2, entire 2 chapters are gone.
And I don't
If you
know.
can't do by parts and you can do sub,
But
the
that's a
first
question.
chapter is gone.
Plugging it
Second
in,
chapter,
seeing if I
can you
could
factor
fix it.
trinomial? You can? Yeah, you could. so it's, DifEq goes like this. Again, heavy on prereqs. For me, Calc 2 is the peak, and then after that just found
Oh, really?
yeah, the very next class was easy for me
Yeah.
because I work at the tourism
Wait,
center,
Calc
so I
2 is easy to read?
no, Calc 2 was telling
But everything else is easy.
I am tomorrow.
Yeah.
All right. I am going to write this as sine squared times sine squared. And unleash power reducing upon this. So I have both of these will produce a half. So half times half is a quarter outside. And I have 1 minus cosine 2x times 1 minus cosine 2x, which I will FOIL to get 1 minus 2 cosine 2x plus cosine squared 2x dx, just to see that I need another power reducing on that term alone. So this is further equal to 1/4, bless you. You need a tissue?
No.
Right. 1 minus 2 cosine two x plus 1/2 1 plus cosine 4x, and now all of this in parentheses dx. Welcome back. We are ready to integrate. 1/4 open parenthesis integral of 1 is x. Integral of cosine is positive sign, so negative survives. And it should be sine over 2, but there's 2 in front, so that cancels. So it's just sine 2x. Now it should be over 2 and 2 in front, and then they cancel. So I'm not writing them. Plus integral of 1 is x, so 1/2 x. Because I have this half in front. And then integral of cosine is sine over 4, so 1/8 sine 4x plus c. I have like terms, this one and this one, so I have to combine those. You don't have to distribute 1/4. So this is going to be 3/2 x minus sine 2x plus 1/8 sine 4x plus c. It's interesting, guys, to spend, a long time working out the equivalency between the Wolfram Alpha, your Mathematica answer, and your answer. They might have the answer in a different form. but then, no, it works. Mark, do you have Mathematica there? Can you please punch our sine to the fourth? I'm interested to see which one is the...
Integral?
Yeah, integrate sine to the fourth, x dx. Mark is going to check for us the answer if Mathematica is going to give the same answer as we have.
Yeah, it gave dx over 8 minus 1 over 4 sine 2x. Plus
Okay,
1
so
over-
Mathematica gave the answer where 1/4 was distributed.
But they don't have plus c, so, minus 1.
Oh, -1 for Mathematica. They actually spell out plus constant. No?
Yeah, I didn't put any limits or anything,
Well, no. If you put limits, then it will compute. Yeah.
but it didn't give me plus c.
All right. Thank you. Guys, we are done with sines and cosines. You have only two possibilities. You have odd exponents and whatever combination, in which case it's u sub. Or you have all even exponents, in which case you use power reducing. Be careful with your algebra and know your Pythagorean identities to switch from one to another. Know your power reducing formulas so you're able to reduce the power. And that concludes sines and cosines. And now we get to secant tangent. I know. So secant tangent pair and cosecant cotangent pair are going to have same rules. Now these can be very tricky. The thing that makes sines and cosines quote quote easy is the fact that derivative of sine is cosine, derivative of cosine is negative sine. So they have this 1-to-1, right? Single cosine, single sine. What you have for these guys is tangent goes into secant squared. That means that you have to keep in mind that you have to keep secant squared peeled off for your trig sub, for your u sub, right? And then derivative of secant is secant tangent. You have to worry about leaving secant tangent as the part for u sub. So these guys tend to be very tricky. So let's take a look at random integral, and I would like to present the way I think about these problems when I see them. So let's say I have secant to the 8 x tangent x dx. Let's say this is the problem. Boom, done, right? I look at this and I say the thing that really pops out, the thing that really stands out for me is this tangent. I have a single tangent. Now, I would love to solve the problem using u sub, if possible. I would love to solve the problem with u sub. So what I do, this is what happens in my head. What I do is, on the side, I just tell myself that the derivative of tangent first, right? Derivative of tangent x is secant squared x, and the derivative of secant x is secant x tangent x. I can peel off. There is a tangent. I have a tangent, right? And I can steal one from here, and I'll be good. Right? If you write this on a side to help you realize these things, it's going to go easier. So I see that if I because this is going to be u, right? And then the whole part over here has to be du. And I already have a single tangent, so I just need to steal one from here, one secant. And I have secant tangent for du, and the 7 secants on the pile are going to become u to the 7. Great. Let's do that. So I am stealing one. And now I see that I have this thing for du. Perfect. Let me set this stuff up. U equals secant x. Du equal secant x tangent x dx. I'm going to underline that red. It's a match. So secant to the 7th, it's u to the 7 du, equals to 1 over 8 u to the 8 plus c, which is 1 over 8 secant to the 8 x plus c. And problem is solved. Looked crazy, right, to begin. But it all worked out nicely because this single tangent, and I was able to steal one. Don't say borrow, because borrowing implies you will return it. I never returned that secant. I just took it, right? So, yeah. Same when they say subtraction with borrowing. Don't return the one you borrow. It's subtraction with stealing. Steal one or forcefully taking, right? Just give it here, right? You don't give it back. So now you have this situation. How about integral of secant to the 5 x tangent, no, secant to the 5, no, secant to the 4 x tangent to the 4 x whatever dx. Would the same u sub work? Yeah, hell, right. Aha. Nope. Oh, the hell is in this thing? Oh, fly now. So, why the little formulas on the side? See which one works? Well, we will have to use eventually. Now I just solved the thing because I told you. Right? If you feel secant tangent, right? You see a unit with 3 and 3, you can't use them. So that means you're not feeling secant tangent. Very good. What are we going to steal? We are going to steal secant squared, right? Leave that for du. So steal secant squared, put it with dx, and leave it for the, now what function will give us secant squared in a derivative? Tangent. So u has to be tangent. But then I have extra secant squared. The identity. You see that? It's going to take practice, guys. These things are not easy. There's going to be a lot of hair loss over this homework. Yep, a lot of hair loss. Mm-hmm. You need the hair loss? Why? Oh, you need the hair. Okay. For the moment, I got concerned. All right, so terrible. There we go. We stole one of the secant squares. Because we are remembering that the derivative of tangent x is secant squared x. So now I have the secant squared dx left for du. The only issue is this guy over here. I have to get rid of it. These two are good. I need to keep that. So keep for du. I need to get rid of the first secant squared. So we get rid of the secant squared by writing what? Very good. So this integral becomes tangent to the 4x plus tangent to the 6x secant squared x dx. U equals tangent x, du equals secant squared x dx, and this is integral u to the 4 plus u to the 6 du. Just flies now, right? Just flies. And what do we do? Exactly. Very good. Very good. I really need a ta-da button. Thank you. Are you good with this? Nah, not yet. Let's see. Tangent to the 4th x dx. Have fun. What's the natural step when you see tangent to the 4th? Well, we don't have identity for the fourth. Very good. So the natural response here is technically the only thing you can do is to write it like this and then start staring at it. Don't ever stare at the main problem, right? See if you can do something that would make, staring at this will never help because we don't have any formula to deal with this. We do have tangent square already in one of our formulas at least. It might not work, but it's better if you're staring at this, right, than at that. Because there's definitely nothing we can do here with formulas. So now you're staring there. See if you can make something happen. Yes?
About what we saw at first, you said these formulas we need. I tried to write down the name but there was stuff on top of
Yes, this will be posted, but those are all in 4.9, all the formulas that I have, and PreCalc 2. So this will be posted right after class, and if you don't have them now, well, actually
I can put them up now because everyone is writing. So those are the,
yeah, I got those.
how about these? And then these are the ones that we are using now for derivatives and integrals. So we are working now tangent and secant are the two. And you see the cotangent cosecant pair has the same form except with minus sign. Right? Good. Did anyone discover the secret? What should we do? Well, I know one person did, but what should I do? Yes. So secant squared x minus 1 times tangent squared x dx, which you can separate into two integrals. And as you can see, the first integral is u sub, right? Is it? The first integral? You have u and you have du. So for the first integral, we write u equals secant x, du equal tangent squared x dx. So the first integral is u squared du. And what's about second integral? What happened for the second integral? This integral here. How do we solve this integral? What can I do with that one?
Secant square of x minus 1.
Yes. So this one is going to be secant squared x minus 1 dx. Nice. So the first integral is 1/3 secant cubed x minus, what's the integral of secant squared? Very good. It's a basic integral. Circle this with whatever you have and say basic integral must know stuff. All right. And then what's the integral of minus 1? It's minus x and the minus in front. And then plus c. Ta-da! There's a button. But
Why is it plus x
yeah,
not minus
it's stapled, yeah. What happened?
No. Yep, correct.
Yeah, the staples button. That was easy. This was not easy. What does it do? You push it, and it says that was easy.
Nobody's ever pushed it. I've never seen anybody do it. Very negative people.
I guess. All right, let's take a look at another problem for you to enjoy. I mean, you guys love this stuff, so why not? Ooh, this is problem 34. You're gonna love it. It might be too easy. Square root of tangent x, secant to the 4th x dx. It kind of gives it away. I don't know.
So did you get to stuff like this? One of the first steps is one I just figured out where split it up. And I found that my u is tangent of x, my d is going to be secant squared. So I rewrote it as the square root of u, secant squared is du, but then I have the secant squared of x. But then I rewrote it as 1 plus tangent squared of x. Now I'm square root of u times 1 plus u squared.
Yeah. Yeah. So then you get secant squared x, right? Yeah. So then you once you break secant squared secant to 4x, you break that up into secant squared x times secant squared x. And then you get yeah, and then from there you can break secant squared x into terms of tangent. Well, one of them. Well, one of them, yeah. You need to keep the other one for it. Yeah. Tangent squared x.
So we have our exponents, right? Exponents are 1/2 and 5/2 because tangent squared, that's going to be 4/2 plus 1/2 is 5/2. Where? Stuff disappeared, but this was over here. So derivative of u squared is u cubed over 3. So that's this piece. Are we all on the same page for 34? We all good? Yes. I'm sorry? Yeah, 10 to the 1/2 and then 10 because I'm transforming this one into 1 plus 10 squared. So 1 times root tangent is tangent to the 1/2. And then you have tangent squared, which is 4/2 plus 1/2 is 5/2. So now this becomes integral of u to the 1/2 plus u to the 5/2 du, which is u to the 3/2 divided by 3/2 plus u to the 7 halves divided by 7 halves plus c, and we bring back tangent. So we get 2/3 tangent to that 3 halves, x, plus 2/7 tangent to 7 halves, x, plus c. I have to wait for everyone to stop writing for the next problem.
Why is that u to the 5/7?
5/7? I have 5 halves
5 halves.
and then 7 halves because plus 1. What happened?
My eyes are not that good.
Would you like my answer?
Sure. Safe, right?
All right. All right, ready? Welcome to Calc2. Good luck. Yes. I put this one on a test. No more 107. This is 107. The first one, after that. It's like $1 million question. And now for $1 million, sec and cube. Now they put the green chili peppers on the menu. That's the one. Now, I mean, when you see the solution, you roll of course. Nope. You realize where you stay, where you sit. Like, why is it being one block? Like, how many? Right here. Really? How many everyone has? You want to see? Yeah. Yeah, tell her.
I know. Wrong. And then I switched that from secant squared x to tangent squared x plus 1.
Work on the little one. I have to look at that. I probably did something wrong. If I, yeah. Look at that. You notice the same thing? And you just said
I thought maybe math changed in the past like 10 minutes, so.
Sure it did.
I'm not, that's, yeah, I mean, I wasn't going to know why it's powerful.
Yeah, I have to check that. One of the problems might be really wrong. Oh, yep. Yeah, we'll fix that. This problem here is wrong. Tangent squared. Tangent to the fourth. Ah! I'll fix this problem. You guys try to work this. Good thing I'm not taking the test. Right? I know, terrible. Which one? The secant cubed? Depends on the mood. No, when you see the solution, to find the solution for this one is really tricky. When you see the solution, you will just say, of course, of course. You will all understand it, no question about it. But to get to that point is just, yeah. And the one after that is worse.
Oh
Yeah,
God.
what he said. He just solved it for all of you. What did he say? Nothing important. Wow. This is the left versus right, all right? So, yeah, you have secant squared x, secant x dx, and then you unleash integration by parts. And integration by parts on this one solves the problem.
Nick,
Yeah.
is integral of secant considered basic integral?
No, that's the next question. The integral of secant is equal to ln absolute value secant plus tangent plus c. That's the integral of secant, and that's the next question. And that one, I'm not going to waste any time asking you to solve anything, because you have to know what to multiply by, like rationalizing kind of deal. And if you don't know it, there's no way to solve the problem. Okay. Now this one over here, when you know how to work out, if you know, looking at this, right, secant squared times secant, you say, oh, I can integrate secant squared, I can differentiate secant, and it's multiplied. As soon as you see multiplication between two functions, your natural response should be integration by parts. Integration by parts is backwards product rule, so it's natural to think about integration by parts as soon as you see two functions multiplied. It is an option for you. Every single integral that has multiplication of two functions, it's viable to use by parts, you know, to try. If it's u sub is not working, integration by parts needs to be considered immediately. You have multiplication of two functions there, and you see that one can be integrated, the other one can be differentiated. So immediately the solution of the setup, You have u, dv, du, and v. You can't integrate yet secant squared. You will after the next example. So secant x goes to be differentiated, and secant squared x dx goes to be integrated. When you differentiate this one, you get secant x tangent x dx, and when you integrate secant squared, you get tangent x. So now, set up the formula, and you get secant x tangent x minus integral of tangent squared x secant x dx. And now unleash u sub, right? Derivative of secant is tangent squared, so u is secant x du is tangent squared x dx. So we have secant x tangent x minus integral of u du, which gives us secant x tangent x minus 1/2 u squared plus c, and bring back x. So secant x tangent x minus 1/2 secant squared x plus c. Not an easy problem at all, because it doesn't fall on the basic integration, right, and basic Pythagorean identities. It actually is by parts, which makes it tricky.
So what do you do in purple? U equals secant square of x, and the derivative of that is tangent square of x?
Derivative of secant is tangent square, right? No, I have it backwards again. Derivative of tangent is secant square.
Yeah, that's what I'm saying.
I don't know. This is the second time I did it.
I've losing my mind.
Me too, guys. I did the same problem over here. I have to fix this issue.
I was like, I don't know what's going on.
Yeah, I have it here as well. I don't know why I'm switching this. My mind is racing like 15 miles per hour. It's empty now. It's gone. So yeah, we have to redo this part. But so far we're good. We're good here. I have the same issue up there. I'm fixing the other one. But what do we do now? What do we do at this point?
You use the replacement problem.
You use the replacement problem. Nice. How do we solve this part?
Oh no, you want subtract.
So what do we have? Let's write the formulas down. Apparently I can't think anymore because I wrote the same wrong formula twice. So derivative of secant x is secant x tangent x. Wow. And the derivative of tangent x is secant squared x. Good. All right. I don't have any of these formulas. They don't work. Because if I pick this, I need another one, right? So I can't do that. If I choose the second formula, great. If I choose the second formula doesn't work either. Interesting. Okay. So what should we do now? I'm sorry? Identity for tangent squared. Let's see what we get. Identity of tangent squared. It's the only thing we can do. Identity is? So, no. It's secant squared minus 1.
Look, now we're back to the same.
Okay? So we have secant x tangent x minus the integral of secant cubed x and plus the integral of secant x dx. Do you see this guy? What do we do? What do we do with this? No. No, you have a minus and a minus is a plus. Right? Are we good there? No.
Oh no, we have that right there. We already did that.
That one. Yes, yes, and yes. Bring it to the other side. You remember the evil problem, the last problem we did yesterday? Last week? You remember this thing? I call it the evil problem. Yeah, half of you didn't come to class because it was after the test, so we can take a vacation. A to the x sine x, we solved, we did integration by parts twice, and we ended up with the same term, right? We did one integration by part, we did a second integration by part, and we ended up with the same term as with the one we started. And then we moved that one to the left, and we got two of them, and then we divided by 2 both sides and had the answer. So now we can use the same trick here. We use the same trick. How much did I write? And now we have 2 integrals of secant cubed x dx is equal to secant x tangent x plus integral of secant x dx. There we go. And this is the reason why the next problem that we have to do is integral of secant x. It's not a basic integral, so we have to solve that integral in order to get this answer. So what I did, guys, is we did by parts, and we followed the algebra, and we came up with the same, with the negative sign, same integral as the starting integral. There is equal sign between these two lines. So now this one is moved to the left, and when you add the two together, 1 plus 1 is 2. So now there's no equal here. It's a new line where 2 integrals of secant cubed x dx are equal to this string. When I add this to this, they are the same. So now our integral of secant cubed x dx is equal to 1/2 secant x tangent x plus the integral of secant x dx. Now in blue, need to solve integral of secant x dx. Now, the way to solve this integral is to multiply secant x by secant x plus tangent x over secant x plus tangent x dx. Now this is something you would not think of, you know, in standard methods of solving integrals. So we have now two integrals. One is secant squared x, well, secant squared x plus secant x tangent x divided by secant x plus tangent x dx. I hope you see that the derivative of tangent is secant squared and the derivative of secant is secant tangent. So u sub u equals tangent x plus secant x, and du is immediately secant squared x plus secant x tangent x dx. So now all of this becomes 1 over u du, which is ln absolute u plus c, which is ln of secant x plus tangent x plus c. Back to the problem. Back to secant cubed x problem. Resuming in black. Integral of secant cubed x dx is equal to 1/2 secant x tangent x plus ln of secant x plus tangent x plus c. Woo! I know, if this didn't make your head explode, I don't know what will. This secant cube problem with a dash of secant integral took the entire page, right? We have just enough time. I don't have time to fix the problem that I did wrong earlier, the tangent to the fourth. I'll have to fix that after the class, and I'll just insert into the notes. So tangent to the fourth problem is wrong. What I need to cover in last 5 minutes of the class is the cosecant cotangent pair. And why am I only spending 4 minutes on it now? Because the exact same thing, you just have to be careful with minus signs. It's the exact same thing. Same ideas, same formulas and everything applies. Same thinking of keeping in mind what's squared, what's not squared, and so on. So cosecant cotangent pair, I start in red, works the same as secant tangent pair with added negatives. You have to be very careful, right? So you are careful that the derivative of cosecant x is negative cosecant x cotangent x, and the derivative of cotangent x is negative cosecant squared x. That's all you worry about. So solving these problems works exactly the same. You know what? Let me go back to the first problem of, what was the first problem we did? Secant to the 8th tangent. Okay, so cosecant to the 8th cotangent. So the problem is cosecant to the 8x cotangent x dx. We peel off again one cosecant to make this string. So integral of cosecant 7x cosecant x cotangent x dx. And now I'm going to underline this as a string for our u sub. U is equal to cosecant x du is equal to negative cosecant x cotangent x dx. I have that string, except I don't have a minus sign. So I'm going to fix the minus sign, and this becomes negative integral of u to the 7 du. So it's negative 1 over 7 1 over 8 u to the 8 plus c, which gives us negative 1 over 8 cosecant to the 8 x plus c. We had 1 over 8 secant to the 8 plus c, and now you have negative 1 over 8 cosecant to the 8. You see that the steps are identical. The only thing you have to worry about is the minus sign. And what I would encourage you guys to actually take all of the problems we did today with secant tangent, rewrite them as the cosecant cotangent, and you will see they all work the same way. All of them. Except you will have this negative in the derivatives, so you have to be a little bit careful with that negative to work that through. So next class, we are going to use these in our trig sub, where you're going to see a problem, say, integral of, I don't know, x squared dx divided by the square root of 100 minus x squared. So you have this problem, you convert it into a trig, and then use what we learned today to solve the trig integral. So we're going to see these types of problems tomorrow, or not tomorrow, on Wednesday. Don't forget about your SI session, extremely important, right? Because of the past exam, right? You can ask Chris all of the questions that you have regarding the exam. And what happened? Yes. And I will see you guys in 2 days. More? This one? All right.
Have a good night.
I have to fix the tangent to the 4th, and then I'll upload everything. I'll upload the lecture notes with the correct tangent to the 4th. If you're watching the stream, tangent to the 4th is still wrong. So fix that. Bye.